Hi guys, so today we are going to be factoring using DOPS. DOPS is just a shortened word for difference of perfect squares. Okay, so please make sure to note that your homework is regular this week, packet checked Wednesday, due Friday, and you have a test on Friday. So please make sure you are ready for that. All right, so the do now. What does a perfect square mean to you? All right, a perfect square is something that multiplies by itself. So if I actually have a real square, I'm talking about equal sides, 2 times 2 would give us a perfect square of 4. Or in other words, 2 squared. Right? So far we've learned 2 types of factoring, and today we're going to learn about the third. There are 3 types of factoring methods. The first one is factoring out a GCF. That's what we did last Monday. And then the rest of the week we practice factoring trinomials when it's 3 terms. And now today is the last method, and that's going to be on DOPS, or difference of perfect squares. You're going to have a mini quiz at the end of today, and it's going to have 1 question from each of these categories. So perfect squares. Let's just quickly review this. 1 squared is 1 times 1. That equals 1. 2 squared is 2 times 2. That equals 4. 3 squared is 3 times 3. That equals 9. 4 squared is 4 times 4. That's 16. And so on. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. All right, so all of these are perfect squares. So when, oops, sorry, I made a mistake. Not 89. All of these are perfect squares. So when you are doing these problems, you are going to be looking for these numbers specifically. That's why we're making this list. All right. So when you are looking for DOPS, or how to factor DOPS, okay, one, you need a binomial. And that means 2 terms, which is what we went over on Friday. You also need it to have a subtraction, because the word difference of perfect squares, remember, difference means subtraction. Okay, so you need it to be a binomial, you need it to be subtraction, and you need it to have 2 perfect squares. Okay, so what I mean by that. So let's check it. So x squared is a perfect square because it multiplies with x and x. And 36 is a perfect square because it multiplies 6 times 6. So we have a binomial, check. We have subtraction in the middle, check. And we have 2 perfect squares, check. So we are good to go. So this is how DOPS works. Basically, after you've identified the 2 perfect squares, you set up 2 parentheses. Okay, your x are going to split up and go in one and the other. Then you're going to do the same. You're going to do the same with the numbers and split those up. And then in order to get a negative in the middle, or difference, we need 1 positive and 1 negative. Okay, and that's always going to look this way. And that's it. That's how easy DOPS is. All right, so my factored form of this is x plus 6 and x minus 6, both in parentheses. Let's try another one. So let's go through our checklist. Is it a binomial? 2 terms. Yes. Is it subtraction in the middle? Yes. So subtraction, 2 terms. All right. Do I have perfect squares? Let's check that out. So how do I make x squared? X times x. But this is a 4x squared, so I need 2 times 2. Is that a perfect square? Yes. What about 1? 1 times 1. So we have perfect squares. So I have all those three things. I'm going to set up my 2 parentheses. Again, I'm going to split up my x's, 2x and 2x. Then I'm going to do the same with my numbers, 1 and 1. And my 2 signs in the middle, one's going to be a positive, one's going to be a negative in order to get that negative. Doesn't matter which one you put first. That's it. That's how you factor that. Okay? So why don't you try the next 2 examples, all right, and then pause this video, and then you can check your answers with me. Okay? All right, so at this point you've tried these. You would see that all of these examples are DOPS examples, right? But don't be fooled because not all binomials are DOPS examples, right? Because of that subtraction. Has to have subtraction in between. So 64, a perfect square, is 8 times 8. 49x squared is 7x times 7x. My 2 parentheses. Now, be careful with this one. When you put this in order, whatever was your first term, so the number was the first term here, I need my number to also be the first term in the set of parentheses. So in the last 2 examples, the x was first, but now I want to make sure my number is first because the number is first in the example itself. And the variable is second, so my 7x's are going to go second. 1 positive, 1 negative. Okay, and last example, y to the 4th. Now when I have a bigger exponent, I still need it to be a perfect square. So I have to see, does it multiply with something and itself? Yes. So what I mean by that is y to the 4th can also split into y cubed and y1, but they're not the same, so that's not a perfect square. So I need something that's the same in order for it to be a perfect square. All right, and then x's is x times x. I set up my 2 parentheses, and I have y squared, x and x, plus, minus. Okay, and that's it for DOPS. So, what you're going to do is you're going to practice. The front page of the practice will be graded as a learning goal. That's your mini quiz, those 3 questions. You're just going to choose one column. You do not have to do both. And then after you're done with the front, the back page is extra practice. Finish those questions for a raffle ticket. And we'll draw a raffle at the end to get a prize. So once you're done with the quiz, call us over to give you some raffles for the back page. If you are not sure that you want to start the quiz just yet and you want to do some practice, try it on the back. But please make sure to give yourself enough time to do the quiz because it is getting graded. Only the front is getting graded. All right, good luck.